So the concept that we are going to see today is enqueue, which means inserting element inside the queue. So here in this diagram as well, you can see how we are inserting an element. Let's try to understand this concept programmatically. So yes, the very first function from the concept queue is insert operation. So we are going to see this function. Here I have already written down the function for you. So line by line we are going to see how this code is executed so that it becomes easy for you to understand. And for understanding this code, I hope you have seen the concept, basic concept of queue. The video is already uploaded for it. So go check that first, get your concepts clear so that this becomes easier for you to understand. Let's try to understand step by step how insertion of element is done in a queue. So the function that I am using here is insert queue. Okay, I want to insert the element. So the very first line that you see is int num. Int num. What do you do by int num? This variable will be storing the value that you want to insert. Right? The next line that I see is if condition. Now what happens in this if condition? Here I am trying to check, is my rar equal to max size minus 1. Now to understand this, let's draw a queue first. Suppose I have my max size for queue at 5. Okay, that means 5 elements are to be stored. 1, 2, 3, 4. Okay, so this is how my queue would look like. The name of this queue also is kept queue only, so I have named it as queue. You can name it anything. Now we are trying to insert the element. Do you remember the concept of insertion? There are two things that are working in your queue, that is front and rear. Your rear is incremented when you are inserting. Your front is incremented. Both are incremented. Okay, your front is incremented when you are deleting. So make note of this. We are going to work on this. So for this, I have a if condition over here where what I'm trying to check, my rar is equal to max size minus 1. Has this rar reached maximum size of my queue? Maximum size of my queue. Now why max size minus 1? Maximum size is 5. Numbering starts from 0. So 0, 1, 2, 3, 4, total of 5. So I need to check whether my rar has reached its limit. And how will I know its limit? If my rar is equal to max size, that is 5 minus 1, 4. So if my rar has reached at this position, that means what? It is at the end of my queue. Now, why am I checking this condition? Because I'm trying to insert the element, and just like stack, if my queue is full, I will not be able to insert the element. So for me to understand whether there is space in my queue or not, I am checking the space by putting this if condition. How will I check it? If my rar has reached its end, and what is the end? Max size minus 1. So if rar has reached max size minus 1, so you put the message printf queue is full. Okay. Now, if it is full, obviously I'm just going to print it to the user. But if it is not full, I can insert the element. Now how do I insert the element? Look here. Printf, enter element to insert. So I'm giving user a choice to give me the element. After that, scanf %d and num. Can you see this num that was declared here? So I'm accepting a number from user and storing it in num. After that, now I want to insert the element. What is the concept for inserting? Rar has to be incremented. So wherever is my rar, increment it first. Now in this case, there are no elements at all. So that means what? My front and my rar are minus 1. And for concept of inserting, you have to increment your rar. So I'll increment my rar will point to 0. Increment my rar. The concept says increment and then insert. Okay, so I'll increment my rar, and in my queue of rar, queue is the name of the queue, and wherever is my rar pointing, at that position put num. Right? So queue of rar equal to num. So the element that I'm accepting from the user would be put over here, wherever my rar is pointing. After that, this line, if front equal to minus 1. Now, this was the first element, right? So first element, before that my front and rear were minus 1. So according to the queue concept, whenever your front and rear are minus 1, you have to place both of them to the 0th position. Okay, now I'm inserting. So as of now, I don't know where is my rear. Is it at the starting position or in between or at end? So for that I have written this code that okay, wherever is the rear, increment it. No matter where is your rear, increment it and put the element. But there is one more thing to check, that if front is minus 1, right? If front is minus 1, because I don't know this is first element or not. So if my front is minus 1, make it 0. So my front will also point here. Clear? Like front will point at the first and rear will go on incrementing. So suppose the user wants to insert one more element. There's already an element. My front and rear both are pointing here as per the logic, right? Now user is trying to insert one more element and I'm putting it. So my concept is what? Increment the rear. So my rear which was here will be incremented and now it will point here. And I'll put the element. Increment the rear, put the element. After that, what is this condition doing? Checking is my front minus 1. Now, is my front minus 1 for now? No, it is already at 0th position. That means front is at its position. So, there's no need for me to do anything to the front. And put the element. Insertion. When insertion is happening, only rear increments. Nothing will happen to your front. Okay. So, this is the function of insertion of element in a queue. Very simple. Check the concept first. Once the concept is clear, then move on to the programming. Learn the logic so that it becomes easier for you to implement the logic in programming. Okay. So, yeah.